Hi, welcome to everyone's favourite segment, Mailbag, the first one for 2023. I do have a lot of stuff, so let's go. I'm actually going to start with not a mailbag, because I actually ordered this. It's something that I commissioned. This comes from Bad Dog Designs in the Old Dart, so thank you very much for doing this commissioned work, so to speak. Because this was available it showed up on Twitter, and I really wanted it, but unfortunately someone else nabbed it. So I said, hey, can you make me one? And he said, no wuckers. So here it is. Let's check it out. Wow. Tell you what, it's nicely packaged. Let me have a look, Oh, it's upside down. All the electrons are going to fall out. Oh, I'm going to show you properly before I show me. Look at this. Bit of commissioned artwork. It's a DeLorean, time machine DeLorean made out of parts. Isn't this absolutely brilliant? Wow, I love it. That's going straight to the pool room. Thank you very much, Paul. There you go. It's 88 miles per hour, 1 of 1. Let me get the old Googles on so I can see this up close. That's terrific. I would love to actually have the skills to be an artist. I'd love to sculpt, paint, or do something like this. I probably could, but I don't know. That is absolutely fantastic. Anyway, if you want to check out Paul's designs, or if you want him to commission your own artwork, I'm sure he'll do it for you. Paul, that is absolutely first rate. That is a Bobby Dazzler, straight to the pool room. Thanks, mate. Hi to all my viewers in Germany, and thank you very much, Christopher Redecker from Hamburg. I love Hamburg. I've been there. It's absolutely fantastic. The train museum there, best in the world. Miniature Wonderland, isn't it called? It's brilliant. Trust me, it's worth going to Germany just for that. Anyway, thank you very much. Let's check this out. What have I got here? We have a note. We have some scan me's with the GitHubs. So it looks like, look, it's got a bow tie and everything. Oh, isn't that pretty? Got some SMA cable connectors with miniature coax, and what is in here? Let's check it out. Itty bitty board. Yeah, I'll have to show you this up close. What is it? Aha, it's a do-it-yourself FET probe. Nice, 1.3 gig. So there you go. You can scan that at home. 0.3 to 0.4 puff input capacitance. Nice, times 10. Probe, AC coupled jobby, 100K to 1.3 gig. Do-it-yourself probe. I'm not going to be able to test the performance of it. Oh, no, I think I might have a 1.5 gig scope now. Oh. And here's Christoph's board. It's so tiny, I had to get my macro lens out. It uses a single MOSFET in a common drain configuration. I can't get this off because I'd have to desolder the can on there. But here's the schematic for it. And it's basically just a BF998 FET on there and common drain. And pretty much Bob's your uncle. So inputs on this side over here. We've got ground and the input here because it's common ground, of course. These scope probes aren't floating. You buy the multi-$1,000, even tens of thousands of dollars worth of, the big brand scope probes. They all come with big warnings on them, like 5 volts max, do not float these suckers, and yeah, you can blow up your probe real easy. Anyway, signal out, which would go to a 50 ohm terminated scope, and then you've got power here. I would have preferred to see, which is 5 volt power, I would have preferred to see like another method for powering this thing rather from the little micro coax and SMA, but it could be compatible with other external FET power supplies and stuff like that. But for you do-it-yourself one, I'd probably prefer to see a couple of pads on there or a different way to do it. There you go. It's the maker probe. There's the bottom of it, and nothing special. This ain't special Rogers high frequency material, anything like that. Just regular FR4 will do the job. I'm going to need a few adapters to actually test this. So I've got SMA to B and C here. Then I've got a gender changer, and the same thing over to here. So I can get some banana plugs on there and power that. I got that around the right way, don't I? Yep. What I actually need is a adapter to get this over to a USB. Actually, that would have been handy. But I'm smarter than your average bear, and I can use my SIGGEN output DC level 5 volts. No wuckers. It just so happens that Rohde & Schwarz have sent me the new MXO4 series scope. You've seen this in a previous video, and there'll be some upcoming videos as well. I've also got some exclusive content over on my Odyssey channel on this. But anyway, I've soldered a couple of pins on here because probing is everything with these things. Like, you know, when you're talking about a high bandwidth FET probe like this, like, you're doing essentially custom probing every time, okay? So, like, you'll just, like, solder wires directly on, you'll get little, you know, customized spring contacts, or you'll actually design in to your product. If you know you want to actually measure the performance of it, you'll actually design in specific high-frequency test pads and, you know, all sorts of things like that. But anyway, what I've got here, SigGen 1 is generating the 5 volts DC power, which is going into this thing, and it's got 2 SigGens, very handy. So I'm generating a 500 millivolt peak to peak into 50 ohms because I've got a 50 ohm inline terminator on there, so you don't get any issues with the cables. I've come in guts, or I showed a video coming guts on that before. 100 megahertz, which is the upper limit of this, and I set up my probe here. Specifically, I've put in the 1.5 gig bandwidth with this, which this thing's capable of. For this particular case, for 100 megahertz, doesn't really matter. But anyway, I've set that up. I've got my manual attenuation. There we go, 10 volts per volt. And if I get this around the right way, I can just probe the end of the coax here. There we go. We're talking though, peak to peak, 200 millivolts. I've set up 500 millivolts, but it is 100 megahertz. Getting a nice clean signal on there. But the amplitude's not right. Have I got my probing correct? I think so. Let's double check on our second channel over here. We want to change our source there. And yeah, we're getting our 500, you know, it's 510 millivolts, something like that. Good enough for Australia, near enough. But we're not getting that. Amplitude's a tad off. 200 millivolts peak to peak. And if I change it to 1 meg termination, which wouldn't be right, we're talking, you know, 400 millivolts peak to peak there. But yeah, nah. So the amplitude is off. I'm not sure why. Let me check another frequency. Now starting to suspect that I don't have enough current drive from my SigGen here. The rail could be dipping. Let me just see if the rail's actually there, because there's no test points on it for voltage. 3.94, so 4 volts. That should still be enough. It's dropping a bit under load, but 4 volts should be enough to power it. All right, now we're getting fancy-pantsy. I'm going to use my micro supply powered from the USB port here. I've got it set to 5 volts. You can see it's drawing 9 milliamps there, which isn't much, but anyway, there you go. We're not using the SigGen anymore. Let's try that again. No, we're definitely only getting 220 millivolts, so something is wrong with the amplitude response of that. I'm not sure what. Kind of scratching my head now. Anyway, I think that's enough for the mailbag. If you want me to see, I might actually really tempted to play around with this and actually compare it with one of my high frequency, like commercial FET probes that I've got here on like a high frequency signal, because this Rohde & Schwarz jobby is a 1.5 gig bandwidth scope. So in theory, I can actually do it. So yeah, leave it in the comments if you want me to do that, like as a second channel or maybe even a main channel video. I don't know, I've always wanted to do a video on FET probes, and I've never actually done one, I don't think. Anyway, thank you very much, Christoph. That is very cool. Perhaps I'm doing something dumb. I need to do further testing on that. But yeah, it does actually amplify quite nicely. And I'll put the GitHubs down below if you want to check it out. Thank you very much. Hi to all my Yankee viewers in Raleigh, North Carolina. I recognise the last name on this one, Demcko. I'll link it in down below. Ron Demcko, who is the capacitor expert from AVX, has sent in some stuff. I wonder what it is. Anyway, yes, I was going to do I think I will do a separate video on this, because I suspect you're not going to be able to see what's in here with my regular camera. Okay, what do we got? Got a whole reel of them. Well, not a whole reel, because I can see through it. But, oh my goodness, I don't even want to. Oh, these are going to be insane. These are insane. Thank you. Hi, Dave. Here are 0201s, 01005s, and 008004 multi-layer ceramic capacitors. I thought you'd like to see how small they can be. Threw in some stacked ones as well. Awesome. Are they some of the stacked jobbies? Oh, nice. I'll show you these, and I'll leave these, because if I drop it, I've lost it. It's going to have to go under the serious microscope to see how small these bad boys are. Oh, all the best stuff's made in Japan. Here we go. They don't actually have the type on there, but look at the size of the tape. Can you even peel that off? 475, is that 4.7 mic there? And we've got some other ones, but yeah, look how teeny tot they are. That's just insane. Like, come on, seriously? So there's actually a stacked type cap. In this case, I'm not sure of the package size there, but you've basically got two of those stacked together, and they do this at the factory so that, you know, you can actually turn them into through-hole parts, because then they leverage the manufacturing technology and the volume that they get on the regular parts to create higher capacity parts if, like, space isn't a problem for you. So yeah, that's actually a thing. So yeah, you can buy those from your mouses and your DigiKeys and your whatnots. And this fully potted oddball looking one here, this is actually a 500 volt 205K, so that's 2 microfarads. C1912A, I googled that, but yeah, that's probably like a date code. But yeah, 500 volt caps. So this is either an array of like 4 capacitors, or it could be like 4 parallel caps to actually get the value in there. So let's measure it. And yep, sure enough, if you go across the pins like that, that's 2 mic, and of course we could like go to opposite corner like that. So I think all the ones there are going to be shorted, yep. And if we go between there and there, that should be shorted. But I'm measuring that at 1 kilohertz, but yep, that's shorted. So once again, they actually leverage existing manufacturing, volume production technology, and then just encapsulate it in like a larger value package that people can use for specific applications. And let's have a look at some AVX Kyocera stuff here. And yeah, these are the different process steps to actually manufacturing the capacitors. And that's exactly what's inside a multi-layer ceramic capacitor there. And I've done a video, of course, on how these crack and ways to overcome that and stuff like that. And here's the miniaturization challenge. Yes, 0805, 0402, 0201, 0105, and 008004. That the actual size of the chip is 0.25 millimeters by 0.125 millimeters. That's just insane. And you can see the mounting area ratio just absolutely plummets, and this is why you can do it, because, you know, you can just fit more capacitors per unit volume on your PCB. But it's like how they pick and place 008, 004 caps is just So they've got a roadmap here, and you can see that the 00804 is 6.3 volts, which isn't too shabby, actually. And because you can see that you can get lower voltage ones, but it's only available at the moment in 0.1 mic. But still, that's just nuts. And the fact that you can get a 1 microfarad in an 01005 that's just insane. And here's just an example of how you can do a DC to DC converter with the embedded buck IC like under the inductor like that, and like that's the entire converter. It's just nuts. And then you can surface mount an entire converter. You can pick and place that, and come on, crazy. I already opened this one. It's from Australia, and it just looked like one of these like formal letter things. Anyway, if you want to send something in, send it to EEVblog Mailbag. Got to put Mailbag on it. PO Box 7949, Norwest, New South Wales, Australia, not Austria. Thank you very much, Carsten, from Maylands in Western Australia. Oh, Here we go. A few years ago, I found out that one of my mother's friends worked at Siemens in Munich and had a patent for something he invented. It was filed in 1954 and the patent was accepted in 1960. It's something to do with impulse timing systems and devices. It's a bit difficult for me to understand. Perhaps you could explain it or give the viewers your opinion. Might make a good... Usually, patents are gobbledygook, unfortunately. So it's often hard to make heads or tails of them, really. Because that's a patent attorney's job, is to... kind of like turn your nice idea. Usually engineers have, you know, nice solid ideas and turn them into gobbledygook while still actually kind of sort of saying what it's doing. I also found another patent for impulse storage matrix comprising magnetic cores. I've done a video on magnetic core memory, which is really cool. Sadly, Karl-Heinz Goslar passed away in 2013. Here is a photo of last time I saw him in 2012 in Munich. There he is. Fantastic. Thank you very much. Let's check out his patent, shall we? All right, I won't go into detail on this, but look, we've got some tubes. Good old-fashioned tubes. That's not my thing, but I love, look, inventor. Look, here it is. Got to sign it down here. Terrific. We're talking June 1960 here. So, yeah, it's some sort of counting type system happening here. Impulse timing system and device. So we have a timing diagram here. So what is it doing? I don't know, some sort of pulse synchronization thing, and then it counts or something. Impulse timing system and device. I don't know. Well, we've got some L's and C's here, although this might not be part of it, because sometimes like they put in like existing method. So whether or not like this is an existing method or this is a new one, we'll have to read the details here. But look, so we've got like a delay line thing happening here. So some sort of, yeah, they're tapping off. So I'd say that's some sort of pulse delay type thing. Geez, what's going on in here? What's V1? I don't know. Hey, here's all the text. This invention is concerned with a system for timing impulses. The problem with timing impulses, that is to say, of shifting impulses as to time arises electrical columns, particularly in, relatively short shifts, can be affected by means of delay lines, which may, so that's what we saw probably over there. It made up a series of reactance elements. So-called inductance coil chains constitute an example of this type. I've of course done videos on glass delay lines, ultrasonic delay lines. They're very cool. Yeah, no, it necessitates accurately timed capacitances in inductors. Yes, it does. Moreover, delay line of this nature causes a reduction in pulse energy. Yes, it does. So this invention, here we go. This invention hereafter describes operates in accordance with Knoll method of obtaining time shifts in any desired length without impairing either accuracy or pulse shape. The invention resides in causing an impulse counter, adapted to transmit an output pulse after having received a predetermined number of input pulses. Okay, so it waits for a number of input pulses and then outputs to synchronize it, to be supplied with a series of impulses derived from pulse generators starting from the moment the frequency of the series, a number of blah 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 blah. The contrast, the constituent elements do not affect the accuracy of the time shift. Accuracy depends solely on the constancy as to of the time pulse generator. Okay, right, so they're using a separate pulse generator circuit to give it regular periodic things, and that will determine how it delays it or something like that. Anyway, there you go. It goes on and on. Job of a patent attorney. I'll link in. My brother-in-law Phil is a patent attorney. I've got a video. I'll link it in up here and down below of him talking about patent attorney stuff. But geez, it goes on. What's it actually for though? If anyone knows, leave it in the comments down below. They're the references. And yes, here's the magnetic core stuff. I've done a video showing magnetic core. I've still got that somewhere. It's down in the bunker, but cool stuff. Magnetic core memory. So thank you very much for sending that in. That's most interesting. If you know exactly, precisely how this works and what it's for, leave it in the comments down below. Don't get too many from Bulgaria. Hi to all my Bulgarian viewers, and thank you, Nikola Manilov. Let's check it out. I don't know what it is. It just says printed circuit board. Spoiler alert. Could be anything though. So, launched. Okay, what do we got? We have a note. You know I read the notes later. What is this? Is this a bit of used kit? Oh, no, it's new. It's new. What is it? It's a, looks like a USB pass-through current. Oh, yeah, it's a USB pass-through current meter attachment, which is handy. Okay, you know, you want something like this in your kit. There it is. It's just got the USB, and it looks like that just allows you to whack a current meter in series. I think that's what's going on there. Hi Dave, first of all I'd like to thank you for all the great content. No worries. I've learned more from you about product design, electronics, measurement, equipment, measurement techniques than I did at university. Well, sorry about that. Sorry to hear. Not to mention you are way more entertaining. Oh, thank you very much. My day job is as a senior electronics engineer, embedded engineer, but currently I'm trying to crowdfund my first project on my own brand, Board Outline. Not a bad name. I like that. It's called the USB Power Injector and does what it says on the silk screen. Allows you to easily supply a USB device with power. Oh, okay, external power. So you can use your lab power supply to inject in here, so you can read the current, you can current limit, and you can do all that sort of jazz. And set the voltage if you want to. Like if you're designing a USB product, for example, you want to you don't just want to hook 5 volts up to it. Oh yeah, it works, ship it. No, you want to hook it up to a variable power supply. You want to actually adjust the input voltage up and down to minimum and maximum thresholds so that you know your product can actually handle it. So yeah, rather than dick it, like otherwise you got to like strip cables and dick it around. Like just having a dedicated thing makes it so much easier. Oh, and he says that it makes characterizing power characteristics like current consumption, operating voltage, etc. a lot simpler. Yeah, you don't have to do bodge cables, which I've done many times. It's a pain in the butt. There's no need to show you a better close-up of that, because that's all it is just allows you to inject power in there. Cool bananas. So I'll link in the crowd supply down below. Thanks very much, Nick. Thank you very much, Simon Richards Martin. Got a hyphen in there from Elimo Engineering Limited in the old dart. It got a bit shock tested on the way here. It says battery on the camcorder failed. We've got 2 little boxes here, and what we've got in here is, it looks like well, it's got Elimo Engineering on the back. There you go. Scan me, scan me. What it looks like is like a little, like, you know, Merlin type game. Oh, flishy flash, flishy flash. Aha, this is Simon's business card. Elimo Engineering, you might remember their Christmas tree from EEVblog 1457. And yes, we do use that. We use a lot of the Christmas trees that people have sent in. So let's check this out. Here you go. So we can just, there we go. I'll turn off the studio lights here. So, don't know what that's doing. I should follow the instructions. So it does have a joysticky thing. So in theory, you could probably program that to have like a Merlin type, you know, interface. Done a video on the old Merlin game from the, was it 70s or early 80s? Can't remember. But anyway, there it is. It is it's a business card. So yeah, great for like trade shows and, you know, stuff like that. Although you wouldn't give somebody this as a business card, because obviously that's not gonna, you want something slim. And there's various techniques you can do. Like you can embed chips like into the board, into the actual layers of the board, and make it just as thin as the board. You can embed the chips in there. You've got to do like multi-layer construction and stuff. You've got to do control depth routing and things like that. But you know, all the LEDs and all the chips and everything can actually be embedded, so it literally is as flat as the PCB, but is actually functional. Battery's a bit of a problem, but you can get really super thin ones these days. So yeah, there you go. Business card. Sweet. Thank you very much, Stephen Gallant from Irvine, California. I don't think we've had something from Irvine before. Where is Irvine in California? Anyway, it is a broken something. For those playing along at home, we have the note. And, we've got the I keep forgetting the name of this particular packaging. It does actually have a name, and it's very cool, and DigiKey and others use it. But, yeah, it's just good stuff. So I'm going to keep that as packing material. Oh, I've got a very nice looking something. Something went thud. Ambit, ambulatory infusion therapy. Sounds medical. Whoa. Yep. Yep. That's like one of those like infusion pumps or something, right? Yeah. Ambit pump. So, yep, it does some sort of patient manual. So you can, use this at home? Can you? It's designed for patient use. So, you know, hence why you get a manual, and it comes in a nice little carry case and all that sort of jazz. So, yeah, I don't know what it's actually used for. What do you actually stick in it? Hello, Dave. An unfortunate mountain bike accident, oops, has kept me out of the air for a while just after... yeah, the problem is you went in the air. Bikes are designed to go on the ground. I know what it's like. Just after you go arse over head and it's not fun. Just after surgery on my right shoulder, deploying side, I was sent home with this nerve blocker. It is a neatly unit that could be a good a nerve blocker. What, so they give you a chemical and you, like, do you have a thing in your arm and you're pumping into yourself? What are you? Ropivacaine, Naropin, 0.2% in NS 500 mils for Ambit pump. I don't know. I don't know my drugs. I haven't had too many of them. Whoa, well, the batteries fell out of the arse end. The energizers haven't leaked. Ambit pump, more than pain relief, superior pain control. So you hook this up and yeah, anytime you're feeling the urge, just, oh bugger it, just push the button, come on, just push it. Oh yeah, that feels good. So yeah, this thing, you know, it looks like an IV drip thing, so like you're not going to drink it, so I think it needs to be yeah, you need to have the catheter thing inserted in your arm or whatnot, I would guess, and you just clip that in, you know, because you can go home with it like inserted in your arm and then you just clip this thing in. I don't know, I've never had to use such a thing. I've never been in such a position, so thankfully. So here it is, and look at this on off button. This is really interesting. Look, we can actually switch this on by going like that, and there you go. The LCD comes on, PR14. Whoop, beep, beep. Just give me the good stuff. RX, Pro 5. I don't know. Do I have to hold down that? What do I do? I don't know. Anyway, all it is just a pump in there, I believe. And program number, there you go, basal rate, milliliters per hour. There you go, program 1. So, you know, you want to program 4, or you set your own one to go Burko if it's getting too much. There you go. So, that's all it is. 2-minute teardown. And apparently, ropivacaine is an anesthetic, which they use, or can also use for epidurals and stuff like that, you know. So you give them birth and no, give me the good stuff, and, well, this is what they give you, I think. So it looks like this just pops, that just pops out of there like that. And, yeah, I guess the pump is in there. It turns that, and that will just put pressure on there. Oh yeah, look, you can see there's a bit of, oh, it's used. It's used. I can get some of the good stuff. Hopefully you can see that. Look, you can see that move. There you go. Fluids going in there. And yeah, they just have a wheel that sort of like puts pressure on there and spins it out. You can see it coming out, hopefully. Yep, there you go. And I don't know, what's that, some sort of filter? Something that's, I don't know, it's got a pattern in there. Maybe a filter. It's not hooked up to any sort of sensor thing, so it's not measuring anything, but there you go. That's to check the rotation, optical sensor to check the rotation, I guess. Anyway, I do like the battery compartment here. You go here, it's a bit loosey-goosey, but you turn it a little, like just a little turn extra, and bingo, you got your leaking batteries out of it. They haven't leaked in this case, but you know. I'm going to have to crack that open though. No screws on it. No, I think this sucker's actually glued or ultrasonically welded together. So I don't think we're going to just get clips to get this undone. I may have to Dremel. There's nothing that the Dremel can't fix. Yeah, it seemed to have been, glued. The cases were glued together, but there you go. Yeah, absolutely no surprises. There's just a motor in there with a reduction gear, and that's it. What do we got down in there? Do I see a Freescale part? Do I? What's under here? Don't know why we need this large part here. It's secret squirrel, obviously, but let's get that off. There we go. What do we got? Oh, is that blank? Oh, no, there it is. Just got to get the light at the right angle. NXP jobby. And, yeah, PCF, like, this is old school stuff. So that looks like it's just a Philips LCD. driver, is it? And then you've got the main Freescale processor in there, and Bob's your uncle. Yeah, but that's what you'd expect. Nothing fancy. Awesome. Well, thank you very much for sending that in. Sorry to hear about your accident. Yeah, you come a gutser. When you your bike tries to leave the ground. I know the fun of that, but yeah, not recommended. Eventually, do it enough times, you will come a gutser. Leave it in the comments down below if you've ever used one of these and you've ever had your Ropivacaine or whatever it is. Is it good stuff or not? I don't know. Devastating Dave, the turntable slave, says, don't do drugs, kiddies. Thank you very much, Tor Hugland, if I'm pronouncing that correctly, from Norway. Hold on, hi to all my viewers from Norway. We love the contents of what's in here. Haven't had one for a while, so let's check it out. All right. Get the tongue at the right angle, that's important. And, hang on. Oh, I'm thinking late 70s. No, it looks newer than that. No. Oh, wow. My smell is, it's off this year. Wow. BBC, as in the, no, why would BBC be coming? It's got BBC on it, but no, this is like, it's a Gossin. It's a Gossin. Metrawatt. I do not consider this a vintage molded. Well, this is like late 80s vintage. So yeah, I'd put this at like late 80s vintage, something like that. Oh geez, that knob is, that knob is awful. The pain. Oh no, that's horrific. Oh no, I declare that the worst knob I've ever used in my life. Oh my goodness. Look at this bad boy, would ya? This is a multimeter. BBC's not like the UK BBC. It's Brown Boveri. I guess that's just a company logo, because this is a Gossin Metrawatt, or Metrawatt, made in Germany. Thank you very much for playing. It's got all the specs on there. It is a true RMS jobby. It's your basic volts, amps, ohms, and diodes. But yeah, you've got your inputs here, which these actually do have. Look, well, let's open it up. But these actually do have shutters on them like that. So I stop the leads coming out, I guess. Not sure. Hang on. They're actually, I think they're to put wires in. I think that's like I can see a contact up under there, I think. Yeah, because that doesn't make sense in terms of like, in terms of locking a probe. So I don't know, it's either a probe lock or it's like for putting wires in there. I don't know. Anyway, isn't this funky? I really do like these form factor meters. And yeah, so we've just got the range here. It's auto ranging. It's got, it's got peak. Look at that. But as I said, this is the worst. I'm really having a hard time turning that. Like if I just, oh man, that is truly, that is the worst range switch I've ever used. This one's all right. The feel on that's okay, but this is just nuts. Yeah, let's put some batteries in this thing. Assume they go in there. What is it, a couple of D cells or something? There we go. We've got 4 double A's there. Nice. And I really like this. Look at this. We've got a spare fuse in there, and also a spare fuse holder, like as well, just in case you lose that. Nice attention to detail. Love it. Let's try and power it up. And I really like this power switch. We'll turn it on, see if it works in a sec, but you can see that there's actually a thing up here that presses into the switch to switch it off when you close the case. Isn't that beautiful? I should have put the battery cover back on. Anyway, whoa, beeping. Beep. Whoa. Whoa. There you go. That's not too shabby at all. In fact, but the viewing angle looks good on the camera, but for me, up above, like it starts to look quite poor. And yeah, that LCD is not the best, but look at that big ass bar graph on there. Anyway, it looks like it's got 3-volt diode range. Ohms, way. Whoa. Okay, there you go. That bar graph is a bit how you doing. What the heck? It's got like, yeah, okay. All right, a bit of lag on it, but whoa, and it's going down, down, down. A few of the segments are starting to fade, but you know, you expect that for the age, but I reckon this is going to be bang on. Damn thing keeps beeping at me. Anyway, oh yeah, there we go. She works. It's reasonably fast responding. Let's try the look at that, auto ranging. Yeah, auto ranging's a bit slow, but there you go. And whoa, is that the... It will actually do a buzzer, but no, that's possibly the worst one I've ever seen. How do I turn the beep off? It's actually got data storage, has it? Interesting. Range, we can auto range. You already beep, it seems to beep at bloody everything. Oh, okay, we're over here. That's what this thing is. Ugh. Reference delta, reference percentage. Wow, really? Ref and set, how can we just, what's N? I don't know. N is no, okay, so I set a reference. Measure a 10K reference resistor. Oh, that's not too shabby. Oh yeah, there you go, bang on. And the other interesting thing about this is 4.5 digit, or actually 30,000, seems to be 30,000 counts. So let's measure a battery. You will note I'm using a made in Germany battery, thank you very much. 1.3387. 1.3393. Oh, pretty close. Well, let's crack it open. I love how it uses flathead screws on here. Yeah, leave it in the comments if you ever used one of these bad boys. This would have been kick-ass back in the day. I'm curious to know the date. Wouldn't surprise me to find through-hole parts in here. Seems to be some sort of catch on here that lifts this whole thing up. Well, there doesn't seem to be any secret squirrel screws on the bottom, and these are just like really brittle feet. These are just like gone the way of the dodo. They're just crumbling everywhere. Aha, that's the trick. You got to close it, and that, whoa, opens up like that. Oh, it's well shielded. Look at that. Nice metal threaded inserts. Yeah, this is going to be a Bobby Dazzler, I think. I'll tell you what, someone's really gone to town designing this thing. It's quite something. They've gone down the rabbit hole, they've chosen the form factor, and they've gone all the way down the rabbit hole. There we go, we're in. Got a insulating sheet on the back of that, of course. And ta-da, yep, as I suspected, through hole. I can see surface mount and some MILF jobbies down on the bottom board, so we're going to get to those. But, oh, yeah, how does it lift out? That looks like the range switch, because that's in the same position as the range switch. This looks like the battery contacts, which come over to the board, but I can't get that out because there's a plastic stand on. Oh, there you go. It does all lift out. I don't have to unscrew. Oh, yeah. Yeah, check it out. Okay. Ta-da. Wow. Look at that. And shielding on there as well. This is very impressive. Got rubber membrane keys there. And there's those horrible range switches I told you about, and the big rocker here, the big power rocker, goes onto the top board there. Wow, that's really something. They're soldered in. We can flip it open though. We can probably like sandwich it open. Check out these custom standoffs that they've manufactured. Really quite funky. They've gone to a lot of effort, haven't they? This is it's really quite something. I'll get back to you once I figured out how to get it apart. Well, none of that gold flash pad rubbish on this. Tin plate all the way. Thank you very much. Wonder it hasn't tarnished over the years, but anyway, we've got an NEC jobby down there, and what's this ribbon cable down here going over to here for? Oh, that'd be the LCD. Okay, right. Yeah, of course. And you got to be careful lifting these up. Dip. Oh, look at that dual wipe. Oh, just a standard dual wipe thing. Anyway, yeah, like old school. Yeah, this has like, you know, early 80s construction written all over it. 87, 24. But yeah, I reckon, so I assume that's 24th week 87. We'll verify that with a couple of others. But yeah, this would have been designed in early to mid 80s. Like they could have manufactured it for quite some time, so it could be an early 80s design. Oops, I accidentally pulled out a wire there. That's one of the battery contacts. That looks like a, oh no, it's just a, like a clamp thing for the wires. That's interesting in its own right. Anyway, I should be able to shove that back in, be able to find some information on that NEC jobby, but looks like, up here, well, check out the range switch first. Isn't that a multi-level Bobby Dazzler? Wow, 4 different wafers. Wow, that's really something. That's very impressive. Very impressive bit of kit. What have they got there? Is that some sort of big carbon resistor? Anyway, got 4 big power diodes up here in bridge configuration. And oh, this is fancy pantsy. Look at that. We've got it. Well, we have ourselves probably a laser trimmed ceramic input divider there. Yeah, that's really quite something. Wow. Okay, a few nice trimmer caps in there. Look at those jobbies. But all the brains of the outfit is that Maxim part. Oh, Maxim, they were the go in the day. Couldn't get them. You could get samples, but you couldn't get them for quids. A Max 141. I'm going to have to look that one up. Actually, I can't readily find a data sheet on that one. So it's doing the ADC, it's doing all the business. Because there is absolutely nothing else on there. And I like this board. Look at this. 4 relays on here. So clunk, clunk, clunk. I didn't hear any relays switching. But yeah, obviously, is that how they're doing, like the auto ranging? Or the manual ranging? I'd have to listen to it more, power it up, listen to it more closely. But yeah, it's just a ribbon cable down to the main board down here. So like there's no other measurement stuff on there. That's it. We've got a little shield around there, but that's just that wafer switch, and there's nothing on the bottom. There you go. It's ultimately very simplistic, but it's based around a Maxim. Well, it looks like, an ADC. We've just got a mux and an op amp there by the looks of it, and that's our reference. All the analog fanboys go wild. It's an AD636 voltage reference, but yeah, that's all she wrote. Very nice ceramic resistor input divider and everything else, but this does true RMS. So I'm rather surprised at the processing simplicity of this thing for its day. Anyway, that is absolutely awesome. Thank you for sending that in. That one's going straight to the pool room. I really like that. It still works. A treat. Of course it does. All these old multimeters usually still work, but anyway, leave it in the comments down below if you use one of these. By the way, I found out BBC is actually part of BBC, Metrawatt, Gossamer, all the companies, I don't know, 3, 4 or 5 of them were merged or interconnected back in the day or something. Now, of course, it's Gossamer Metrawatt. But back then, they were branding this a BBC, and there's ABB as well. I don't know how they figure into it. There's all sorts of stuff I was finding. So anyway, leave it in the comments if you got any further detail on this or you use one. It's just like, it's huge and chunky, but it did the business. 30,000 count back in the day with true RMS was pretty schmick. I've never known Maxim to actually do a multimeter chipset, so I don't think that's a multimeter chipset. I think that's just a Delta Sigma ADC. And I think we'll find that NEC jobby down there is a processor and perhaps with built-in LCD driver as well. Although it could just be serial going over, because that's not enough, pins. No, the LCD must have its own driver inside there. So, probably like a Hitachi chipset. Something like that. Yeah, ADC and processor doing all the smarts, and then LCD driver.